purpose. As a recommended practice of the Association for Advancement of Cost Engineering, the Cost Estimate Classification System provides guidelines for applying the general principles of estimate classification to project cost estimates, i.e., cost estimates that are used to evaluate, approve, and fund projects. The Cost Estimate Classification System maps the phases and stages of project cost estimating together with a generic maturity and quality matrix, which can be applied across a wide variety of industries. This addendum to the generic recommended practice provides guidelines for applying the principles of estimate classification specifically to project estimates for engineering, procurement, and construction (EPC) work for the process industries. This addendum supplements the generic recommended practice, 17R97, by providing a section that further defines classification concepts as they apply to the process industries, charts that compare existing estimate classification practices in the process industry, and a chart that maps the extent and maturity of estimate input information, project definition deliverables, against the class of estimate. As with the generic standard, an intent of this addendum is to improve communications among all of the stakeholders involved with preparing, evaluating, and using project cost estimates specifically for the process industries. It is understood that each enterprise may have its own project and estimating processes and terminology, and may classify estimates in particular ways. This guideline provides a generic and generally acceptable classification system for process industries that can be used as a basis to compare against. It is hoped that this addendum will allow each user to better assess, define, and communicate their own processes and standards in the light of generally accepted cost engineering practice. For the purposes of this addendum, the term process industries is assumed to include firms involved with the manufacturing and production of chemicals, petrochemicals, and hydrocarbon processing. The common thread among these industries, for the purpose of estimate classification, is their reliance on process flow diagrams, PFDs, and piping and instrument diagrams, P&IDs, as primary scope-defining documents. These documents are key deliverables in determining the level of project definition, and thus the extent and maturity of estimate input information. Estimates for process facilities center on mechanical and chemical process equipment, and they have significant amounts of piping, instrumentation, and process controls involved. As such, this addendum may apply to portions of other industries, such as pharmaceutical, utility, metallurgical, converting, and similar industries. Specific addendums addressing these industries may be developed over time. This addendum specifically does not address cost estimate classification in non-process industries, such as commercial building construction, environmental remediation, transportation infrastructure, dry processes such as assembly and manufacturing, soft asset production such as software development, and similar industries. It also does not specifically address estimates for the exploration, production, or transportation of mining or hydrocarbon materials, although it may apply to some of the intermediate processing steps in these systems. The cost estimates covered by this addendum are for engineering, procurement, and construction, EPC, work only. It does not cover estimates for the products manufactured by the process facilities, or for research and development work in support of the process industries. This guideline does not cover the significant building construction that may be a part of process plants. Building construction will be covered in a separate addendum. Cost Estimate Classification Matrix for the process industries. The 5 estimate classes are presented in relationship to the identified characteristics. Only the level of project definition determines the estimate class. The other 4 characteristics are secondary characteristics that are generally correlated with the level of project definition, as discussed in the generic standard. The characteristics are typical for the process industries, but may vary from application to application. This matrix and guideline provide an estimate classification system that is specific to the process industries. Refer to the generic standard for a general matrix that is non-industry specific, or to other addendums for guidelines that will provide more detailed information for application in other specific industries. These will typically provide additional information, such as input deliverable checklists to allow meaningful categorization in those particular industries. Notes: The state of process technology and availability of applicable reference cost data affect the range markedly. The plus-value value represents the typical percentage variation of actual costs from the cost estimate after application of contingency, typically at a 50% level of confidence, for the given scope. If the range index value of 1 represents 0.05% of project costs, then an index value of 100 represents 0.5%. Estimate preparation effort is highly dependent upon the size of the project and the quality of estimating data and tools. Estimate Class 5. Level of project definition, 0% to 2%, end usage. Concept screening, methodology. Capacity factored, parametric models, judgment, or analogy. Expected accuracy range, L, -20% to -50%, H, 30% to 100% preparation effort. 1 Estimate Class 4, level of project definition, 1%, 15%, end usage, study or feasibility, methodology, equipment factored or parametric models. Expected accuracy range, L, 15% to -30%, H, 20% to +50%. 2 to 4 Estimate Class 3, level of project definition, 10% to 40%, end usage, budget, authorization or control. Methodology, semi-detailed unit costs with assembly-level line items. Expected accuracy range, L, -10%-20%, H, 10% to 30%. Preparation effort, 3 to 10. Estimate Class 2, level of project definition, 30% to 70%. End usage, control or bid tender. Methodology, detailed unit cost with force detailed takeoff. Expected accuracy range, L, -5 to +15%, H, +5% to +20%. Preparation effort, 4 to 20. Estimate Class 1, level of project definition, 50% to 100%, end usage, check estimate or bid tender. Methodology, detailed unit cost with detailed takeoff. Expected accuracy range, L, -3% to 10%, H, +3% to +15%. Preparation effort, 5 to 100. Characteristics of the estimate classes. The following charts provide detailed descriptions of the 5 estimate classifications as applied in the process industries. They are presented in the order of least defined estimates to the most defined estimates. These descriptions include brief discussions of each of the estimate characteristics that define an estimate class. For each chart, the following information is provided. ANSI Standard Reference, 1972. Name. This is a reference to the equivalent estimate class in the existing ANSI standards. Alternate estimate names, terms, expressions, synonyms. This section provides other commonly used names that an estimate of this class might be known by. These alternate names are not endorsed by this recommended practice. The user is cautioned that an alternative name may not always be correlated with the class of estimate as identified in the chart. Description. A short description of the class of estimate, including a brief listing of the expected estimate inputs based on the level of project definition. Level of project definition required, expressed as a % of full definition. For the process industries, this correlates with the % of engineering and design complete. End usage. A short discussion of the possible end usage of this class of estimate. Estimating methods used. A listing of the possible estimating methods that may be employed to develop an estimate of this class. Expected accuracy range. Typical variation in low and high ranges after the application of contingency, determined at a 50% level of confidence. Typically, this results in a 90% confidence that the actual cost will fall within the bounds of the low and high ranges. Effort to prepare. This section provides a typical level of effort in hours to produce a complete estimate for a $20,000 plant. Estimate preparation effort is highly dependent on project size, project complexity, estimator skills and knowledge, and on the availability of appropriate estimating cost data and tools. Class 5 estimate, ANSI Standard Reference Z94.2-1989 name, order of magnitude estimate, typically 90% to +50%. Alternate estimate names, terms, expressions, synonyms, ratio, ballpark, blue sky, seat of pants, ROM, idea study, prospect estimate, concession license estimate, guesstimate, rule of thumb. Description. Class 5 estimates are generally prepared based on very limited information and subsequently have wide accuracy ranges. As such, some companies and organizations have elected to determine that due to the inherent inaccuracies, such estimates cannot be classified in a conventional and systemic manner. Class 5 estimates, due to the requirements of end use, may be prepared within a very limited amount of time and with little effort expended, sometimes requiring less than an hour to prepare. Often, little more than proposed plant type, location, and capacity are known at the time of estimate preparation. Level of project definition required: 0% to 2% of full project definition. End usage: Class 5 estimates are prepared for any number of strategic business planning purposes, such as but not limited to market studies, assessment of initial viability, evaluation of alternate schemes, project screening, project location studies, evaluation of resource needs and budgeting, long-range capital planning, etc. Estimating methods used: Class 5 estimates virtually always use stochastic estimating methods, such as cost capacity curves and factors, scale of operations factors, Lang factors, Hand factors, Chilton factors, Peters-Timmerhouse factors, Guthrie factors, and other parametric and modeling techniques. Expected accuracy range: Typical accuracy ranges for Class 5 estimates are -20 to -50% on the low side and +30% to +100% on the high side, depending on the technological complexity of the project, appropriate reference information, and the inclusion of an appropriate contingency determination. Ranges could exceed those shown in unusual circumstances. Effort to prepare for $20 million project: as little as 1 hour or less to perhaps more than 200 hours, depending on the project and the estimating methodology used. Class 4 estimate, ANSI Standard Reference Z94.2-1989, name, budget estimate, typically 15% to +30%. Alternate estimate names, terms, expressions, synonyms, screening, top-down, feasibility, authorization, factored, pre-design, pre-study. Description: Class 4 estimates are generally prepared based on limited information and subsequently have fairly wide accuracy ranges. They are typically used for project screening, determination of feasibility, concept evaluation, and preliminary budget approval. Typically, engineering is from 1 to 5% complete and would comprise at a minimum the following: plant capacity, block schematics, indicated layout, process flow diagrams, PFDs for main process systems, and preliminary engineered process and utility equipment lists. Level of project definition required: 1%, 15% of full project definition. End usage: Class 4 estimates are prepared for a number of purposes, such as, but not limited to, detailed strategic planning, business development, project screening at more developed stages, alternative scheme analysis, confirmation of economic and/or technical feasibility, and preliminary budget approval or approval to proceed to next stage. Estimating methods used: Class 4 estimates virtually always use stochastic estimating methods, such as equipment factors, Lang factors, Hand factors, Chilton factors, Peters-Timmerhouse factors, Guthrie factors, the Miller method, gross unit costs ratios, and other parametric and modeling techniques. Expected accuracy range: Typical accuracy ranges for Class 4 estimates are -15% to 30% on the low side and +20 to 50% on the high side, depending on the technological complexity of the project, appropriate reference information, and the inclusion of an appropriate contingency determination. Ranges could exceed those shown in unusual circumstances. Effort to prepare for $20 million project: typically as little as 20 hours or less to perhaps more than 300 hours, depending on the project and the estimating methodology used. Characteristics of the estimate classes. Continued. Class 3 estimate, ANSI Standard Reference Z94.2-1989, name, budget estimate, typically 15% to 30%. Alternate estimate names, terms, expressions, synonyms, budget, scope, sanction, semi-detailed, authorization, preliminary control, concept study, development, basic engineering phase estimate, target estimate. Description: Class 3 estimates are generally prepared to form the basis for budget authorization, appropriation, and/or funding. As such, they typically form the initial control estimate against which all actual costs and resources will be monitored. Typically, engineering is from 10 to 40% complete and would comprise at a minimum the following: process flow diagrams, utility flow diagrams, preliminary piping and instrument diagrams, plot plan, developed layout drawings, and essentially complete engineered process and utility equipment lists. Level of project definition required, 10 to 40% of full project definition. End usage. Class 3 estimates are typically prepared to support full project funding requests and become the first of the project phase control estimates against which all actual costs and resources will be monitored for variations to the budget. They are used as the project budget until replaced by more detailed estimates. In many owner organizations, a Class 3 estimate may be the last estimate required and could well form the only basis for cost schedule control. Estimating methods used. Class 3 estimates usually involve more deterministic estimating methods than stochastic methods. They usually involve a high degree of unit cost line items, although these may be at an assembly level of detail rather than individual components. Factoring and other stochastic methods may be used to estimate less significant areas of the project. Expected accuracy range. Typical accuracy ranges for Class 3 estimates are -10 to -20% on the low side and +10% to +30% on the high side, depending on the technological complexity of the project, appropriate reference information, and the inclusion of an appropriate contingency determination. Ranges could exceed those shown in unusual circumstances. Effort to prepare for 20mm project. Typically as little as 150 hours or less to perhaps more than 1,500 hours, depending on the project and the estimating methodology used. Class 2 estimate. AACE Standard Reference Z94.2 1989 name definitive estimate, typically -5% to +15 cent. Alternate estimate names, terms, expressions, synonyms, detailed control, forced detail, execution phase, master control, engineering, bid, tender, change order estimate. Description. Class 2 estimates are generally prepared to form a detailed control baseline against which all project work is monitored in terms of cost and progress control. For contractors, this class of estimate is often used as the bid estimate to establish contract value. Typically, engineering is from 30% to 70% complete and would comprise at a minimum the following: process flow diagrams, utility flow diagrams, piping and instrument diagrams, heat and material balances, final plot plan, final layout drawings, complete engineered process and utility equipment lists, single-line diagrams for electrical equipment and motor schedules, vendor quotations, detailed project execution plans, resourcing and workforce plans, etc. Level of project definition required, 30 to 70% of full project definition. End usage. Class 2 estimates are typically prepared as the detailed control baseline against which all actual costs and resources will now be monitored for variations to the budget and form a part of the change variation control program. Estimating methods used. Class 2 estimates always involve a high degree of deterministic estimating methods. Class 2 estimates are prepared in great detail and often involve tens of thousands of unit cost line items. For those areas of the project still undefined, an assumed level of detail takeoff, forced detail, may be developed to use as line items in the estimate instead of relying on factoring methods. Expected accuracy range. Typical accuracy ranges for Class 2 estimates are -5 to -15% on the low side and +5 cent to +20% on the high side, depending on the technological complexity of the project, appropriate reference information, and the inclusion of an appropriate contingency determination. Ranges could exceed those shown in unusual circumstances. Effort to prepare for 20mm project. Typically as little as 300 hours or less to perhaps more than 3,000 hours, depending on the project and the estimating methodology used. Bid estimates typically require more effort than estimates used for funding or control purposes. Class 1 estimate, AACE Standard Reference Z94.2, name definitive estimate, typically 95% to +15%. Alternate estimate names, terms, expressions, synonyms. Full detail, release, fallout, tender, firm price, bottoms up, final, detailed control, force detail, execution phase, master control, fair price, definitive, change order estimate. Description. Class 1 estimates are generally prepared for discrete parts or sections of the total project, rather than generating this level of detail for the entire project. The parts of the project estimated at this level of detail will typically be used by subcontractors for bids, or by owners for check estimates. The updated estimate is often referred to as the current control estimate and becomes the new baseline for cost schedule control of the project. Class 1 estimates may be prepared for parts of the project to comprise a fair price estimate or bid check estimate to compare against a contractor's bid estimate or to evaluate dispute claims. Typically, engineering is from 50% to 100% complete and would comprise virtually all engineering and design documentation of the project and complete project execution and commissioning plans. Level of project definition required: 50% to 100% of full project definition. End usage. Class 1 estimates are typically prepared to form a current control estimate to be used as the final control baseline against which all actual costs and resources will now be monitored for variations to the budget and form a part of the Change Variation Control Program. They may be used to evaluate bid checking, to support vendor-contractor negotiations, or for claim evaluations and dispute resolution. Estimating methods used. Class 1 estimates involve the highest degree of deterministic estimating methods and require a great amount of effort. Class 1 estimates are prepared in great detail and thus are usually performed on only the most important or critical areas of the project. All items in the estimate are usually unit cost line items based on actual design quantities. Expected accuracy range. Typical accuracy ranges for Class 1 estimates are -3% to -10% on the low side and +3% to +15% on the high side, depending on the technological complexity of the project, appropriate reference information, and the inclusion of an appropriate contingency determination. Ranges could exceed those shown in unusual circumstances. Effort to prepare for $20 million project. Class 1 estimates require the most effort to create and as such are generally developed for only selected areas of the project or for bidding purposes. A complete Class 1 estimate may involve as little as 600 hours or less to perhaps more than 6,000 hours, depending on the project and the estimating methodology used. Bid estimates typically require more effort than estimates used for funding or control purposes. Comparison of classification practices. Figures 3A through 3C provide a comparison of the estimate classification practices of various firms, organizations, and published sources against one another and against the guideline classifications. These tables permit users to benchmark their own classification practices. Comparison of classification practices. AACE Classification Standard, Class 5, Order of Magnitude Estimate, -30% to 50%. Class 4, Budget Estimate, 9 to 15% to +30%. Class 3, Budget Estimate, 15% to +30%. Class 2, Definitive Estimate, 5% to +15%. Class 1, Definitive Estimate, 5-15%. ANSI Standard Z94O. Class 5, Order of Magnitude Estimate. Class 4, Budget Estimate. Class 3, Budget Estimate. Class 2, Definitive Estimate. Class 1, Definitive Estimate. AAC pre-1972. Class 5, Order of Magnitude Estimate. Class 4, Budget Estimate. Class 3, Budget Estimate. Class 2, Definitive Estimate. Class 1, Definitive Estimate. Association of Cost Engineers, UK. AACE. Class 5, Class 4, 30% to 30%. Class 4, Budget Estimate, -15% to 30%. Class 3, Study Estimate, -20% to +20%. Class 2, Budget Estimate, -10% to 10%. Class 1, Definitive Estimate, 5% to 5%. Norwegian Project Management Association, NFP. Class 5, Concession Estimate. Class 4, Exploration Estimate. Class 3, Feasibility Estimate. Class 2, Authorization Estimate. Class 1, Master Control Estimate. American Society of Professional Estimators, SPE. Class 5, Level 1. Class 4, Level 2. Class 3, Level 3. Class 2, Level 4. Class 1, Level 5. References. 1. John R. Heiselman, Arco Oil and Gas Co., 1988 AAC's Transactions, Paper V3.72. K.T. Yeo, The Cost Engineer, The 27, Number 6. 1989. 3. Stevens and Davis, BP International Limited, 1980 Transactions Paper B4.1, Class 3 is inferred. 4. Peter Barenbruck, BHP Petroleum article in Petroleum Technology, August 1993. These comparisons help users to align their estimate classification practices with industry standards, ensuring consistency and accuracy in cost estimating. Estimate Input Checklist and Maturity Matrix. The following checklist maps the extent and maturity of estimate input information, deliverables, against the 5 estimate classification levels. This is a checklist of basic deliverables found in common practice in the process industries. The maturity level is an approximation of the degree of completion of the deliverable. The degree of completion is indicated by the following letters: none, blank. Development of the deliverable has not begun. Started. Work on the deliverable has begun. Development is typically limited to sketches, rough outlines, or similar levels of early completion. Preliminary. Work on the deliverable is advanced. Interim. Cross-functional reviews have usually been conducted. Development may be near completion except for final reviews and approvals. Complete. The deliverable has been reviewed and approved as appropriate. General project data, project scope description, Class 5 General, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Plant production facility capacity, Class 5 Assumed, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Plant location, Class 5 General, Class 4 Approximate, Class 3 Specific, Class 2 Specific, Class 1 Specific. Soils and hydrology, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Integrated project plan, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 1 Defined. Project master schedule, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Escalation strategy, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Work breakdown structure, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Project code of accounts, Class 5 None, Class 4 Preliminary, Class 3 Defined, Class 2 Defined, Class 1 Defined. Contracting strategy, Class 5 Assumed, Class 4 Assumed, Class 3 Preliminary, Class 2 Defined, Class 1 Defined. Engineering deliverables, block flow diagrams, Class 5 Started Preliminary, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Class 5 Started, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Process flow diagrams, PFDs, Class 5 Started Preliminary, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete utility flow diagrams, UFDs, Class 5 Started Preliminary, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Piping and instrument diagrams, P&IDs, Class 5 Started, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Heat and material balances, Class 5 Started, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Process equipment list, Class 5 Started Preliminary, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Utility equipment list, Class 5 Started Preliminary, Class 4 Preliminary, Class 3 Complete, Class 2 Complete, Class 1 Complete. Electrical one-line drawings, Class 5 Started Preliminary, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1 Complete. Specifications and data sheets, Class 5 Started, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete. Classroom equipment arrangement drawing, Class 5 Started, Class 4 Preliminary Complete, Class 3 Complete, Class 2 Complete, Class 1, complete. Spare parts listings, Class 5. Started preliminary, Class 4, preliminary, Class 3, complete. Class 2, complete. Class 1, complete. Mechanical discipline drawings, Class 5, started. Class 4, preliminary. Class 3, preliminary, complete. Class 2, complete. Class 1, complete. Electrical discipline drawings, Class 5, started. Class 4, preliminary. Class 3, preliminary, complete. Class 2, complete. Class 1, complete. Instrumentation control system discipline drawings, Class 5, started. Class 4, preliminary. Class 3, preliminary, complete. Class 2, complete. Class 1, complete. Civil structural site discipline drawings, Class 5, started. Class 4, preliminary. Class 3, preliminary, complete. Class 2, complete. Class 1, complete.